Alright, we're ready to start our next unit, and it's going to be systems of equations, and we're going to begin by graphing systems of equations to solve them. Okay, this slide starts our vocabulary. We actually have 5 slides with vocabulary, so what you're going to do is what we usually do. Pause the video when you get to the vocabulary, write everything down, and restart when you're ready to go. So, pause the video now, write down your vocabulary, read through it, and make sure you understand. Here's our next vocabulary word. Pause the video, write it down, restart when you're ready to begin again. Alright, we got slide number 3. So, once again, same procedure. Pause it, write it down, restart when you're ready to go on to the next word. Alright, you're almost there. Remember, make sure you get all this information down because we'll be using all of these terms throughout the rest of the video. Alright, last one, I promise. So get this information down, and remember, I'm going to be using all these words: consistent, inconsistent, dependent, independent, all through the video. So make sure you understand what it means. Review the vocabulary before you go on. So pause and write down this information now. Oops, I miscalculated. There's actually 6 slides of vocabulary, so last one, I promise. So get all this information down, make sure you understand what the words mean. So pause and restart when you're ready to go. Alright, so let's work our first example here together. First of all, everything's already graphed for you. So what we're going to look at is we're going to look at these 2 sets of equations here first. This is our x minus 1 right here. They're already graphed for us and labeled. And y equals negative x plus 4. Alright, if you'll notice these 2 lines when you look at them, like here's one and here's the other. Those 2 lines don't look like they cross, but let's check and examine them. First of all, slope of each line is a negative 1 because no number in front of there, in front of the x, so that means there's an implied 1. So it is negative 1 and negative 1. They have the same slope, but they have, this one has a y-intercept of 1, this one has a y-intercept of 4. So, same slope, different y-intercept. That means they're parallel lines, so this system is inconsistent. And an inconsistent system means there is no solution. Alright, now let's look at B. So here's our B, and we have this equation here, 3x minus 3y equals 9. It is the line that goes down through here, and we have once again the negative x plus 1. If we look, these 2 lines cross at exactly 1 point. You see them crossing right here, so that means there is, that point where they cross is our solution, so there is one solution. Alrighty, let's look at our last one. They're already graphed here. It is x minus y equals 3, which is this line, and 3x minus 3y equals 9, which is this line. They are the same line. It's right there. You can see it right there. So if they are the same line, that means that every point on that line is a solution. So there is infinite solutions to this one. Alright, next example. This one's not graphed for us, but we're going to have to graph it ourselves. Remember, we want it in slope-intercept form because it's our blueprint for creating a graph. What we're going to do is we're going to graph this one first. So we're going to go to, let's see, 8, 2, 3, 4, 5, 6, 7, so 8 should be about right here. And remember, we start with the y-intercept, so that is 8 on the y-axis. And from there, we're going to use our slope. No number in front of the x, but I got that implied 1, so my rise over my run is negative 1 over 1. So I'm going to go down 1 and over 1, down 1 and over 1, down 1 and over 1, and I'm just going to keep going to try to make my line a little bit better. All right.
Good morning.
Good morning. All right, so now we're going to graph our second one. So it's already in slope-intercept form, so good for us. We don't have to do anything to manipulate it. So we're just ready to go ahead with the graph. Remember, blueprint for creating your graph is your slope-intercept form. And we start with the y-intercept. Vertical one is the y-axis. So I'm going to go down to -7 because there's a negative sign in front of there. So 2, 3, 4, 5, 6, 7. So that's my starting point there. And then I'm going to use my slope. Remember, your slope is always attached to your x. And I want to rise over my run. So since that's a whole number, an integer, I can put it over 1. 4 is my rise. 1 is my run. So I can go up 4. 1, 2, 3, 4. And over 1. And then up again. 1, 2, 3, 4. And over 1. And then I can go up again. 2, 3, 4. And over 1. And this is my second line. Alright, so this one, since they have a different slope, I knew I was going to have one solution, and this is my solution here. It's where these two lines cross. And that is the point 1, 2, 3, the point 3, comma, 1, 2, 3, 4, 5. That is my solution there. The point where they cross, 3, comma, 5. My x coordinate's 3, my y coordinate's 5. So that's that example. Alright, so here's our next example. On this one, it's not already in slope-intercept form, so we're going to have to put it in slope-intercept form. So we're going to do that with the first equation. Slope-intercept form is y equals mx plus b. I'll write that at the top. And what that means is we want y by itself. So I've got to get rid of everything with the y. So basically what I'm doing is I'm picking up this x and I'm moving it to the other side. And when I do that, it becomes negative. So I don't have an x over here now. But I still have a 2 in front of that y. And remember, when I have a number in front of a variable, it means multiplication. So I have to divide. So, and then these cancel out. And my equation in slope-intercept form is this. I'm going to rewrite this equation at the top so you can see it. Here's the first one. I'm going to have negative x over 2 plus 5 halves. Alright, now I'm going to solve the second one. Same thing. I want y by itself, so I need to get rid of that 2x. I'm going to move it over here. So then it's negative when I move it to the opposite side. I do that by subtracting it from both sides. So move it to the opposite side. It makes it have the opposite sign. Then I have a 4 in front of that y. I need y by itself, so I've got to get rid of the 4. So I divide by 4. So my second equation ends up looking like, let's go pen writing y equals negative x over 2. And that is a plus, and that reduces down to 1/2. Alright, I can already tell here I've got slopes that are the same, negative 1/2 and negative 1/2. They have different y-intercepts. So I'm going to have two parallel lines, and there's going to be no solution, but my directions say graph it. So I'm going to graph it. First of all, this first one, my y-intercept is 5 over 2, which is 2.5, which is about right there. And then my slope says I go down 1 and over 2. So this is this line. And it's really hard to graph this with the stylus, so I'm doing my best. And let's graph the other one. My y-intercept is 1/2. And my slope is the same, negative 1/2. So I go down 1 and over 2. So there's what my lines look like. And because they have the same slope, and different y-intercepts, I know they're parallel. That fits the definition of a parallel line. And because they're parallel, they never cross, so that means there's no solution. Alright, so why don't you give this one a shot yourself? So put it in slope-intercept form, compare your slopes, compare your y-intercepts. That should tell you whether you're going to have no solutions, one solution, or infinitely many. And then graph it. Once you have got that done, restart the video and check your answers with mine. So go ahead and pause and give it a shot. Alright, when I graphed mine, actually when I got them in slope-intercept form, if you look up here at the top, they have the same slope, the same y-intercept, so that means they are the same line. So what that means is if they're the same line, every ordered pair on that line is the solution. So there is infinitely many solutions to this one. Alright, so that's it for graphing. We're not going to do another example. We'll work on some stuff in class. So that's it, and we'll see you tomorrow.